So, ladies and gentlemen, hello. Hi everyone, and my name is Ievgen Burdin. Let me introduce myself in a few words. Can I speak without microphone? No? Okay, for streaming we need. All right, let me introduce myself in a few things, few facts about me. So I live in Munich. I came here by Camper One. I work in for Tech5 agency. Love dogs, love sports activities and adventure. Yeah, I think that's it. Today I'm going to overview how to unlock power of clean architecture for our code design solutions. Clean architecture is software design philosophies defined by Uncle Bob, and it helps us to make our code base or our code make more maintainable, testable, and readable. And what also? I forgot. Okay. Why I think it's important to us? Usually, if we have some small idea, we can't imagine how much amount of code we will have in the end, or how much rows we will have in the end of our project, or in the implementation of our small idea. So, why it can be helpful? Because we can implement it from, we can use this approach for implementation from scratch until the production. From other side, if we talk about production code, it's also possible that once we write a code, this code works well for us locally, also in cloud, on some other production service. But then something happened, and another developers will have our bug. We'll have to fix our bugs or work or improve our code. So that's why I think, and for me, the clean architecture is useful and yeah, and a good decision to make code more clean. So, as I said, clean architecture gives us the key benefits. It makes our code maintainable, scalable, portable, and testable. Let's review some details. What about maintainability? The clean architecture enforces clear separation of concerns, make code base more modular, independent of external libraries and frameworks, make it easier to identify, update, and maintain different parts of an application, protect us to avoid ripple effects across the system, and helps to improve robustness of our code. If we talk about scalability, clean architecture decouple the core business logic from an external dependencies, enable to add new features or components without major architectural changes, allows easier scaling parts of an application, and by enforcing separation of concerns. If we talk about portability, it allows us to easy to switch between platforms, frameworks, external libraries, such as external libraries and services, such as databases, storages, environments, and so on. It becomes more. It becomes possible because such approach makes business logic independent of external dependencies, libraries. So what about testability? It promotes writing modular and isolated unit tests of components, make it possible to unit test an individual part of the system, improve code and test quality, reduce possible amount of bugs and enhance confidence of tests and make the system more robust. So we can overview the schema of this approach. So we can see on the left picture, we can see in the middle, in the center, the entities. So entities, it's enterprise-wide business rules. It's encapsulate enterprise-wide business rules. An entity can be an object with method or can be a set of data structure and functions. They encapsulate the most general high-level rules. This layer should not be affected by changes of external layers. I mean the controllers or interfaces or use cases. The next layer is use cases. The code in this layer contains application-specific business rules. It encapsulates and implements all of the use cases of the system. These use cases orchestrate the flow data from and to entities. Possible changes on this layer should not affect entities layer. We also not expect this layer to be affected by changes on external levels, such as interface to databases, storages, UI, or some other things. Interface and adapters. The code on this layer is a set of adapters that convert data from format most convenient for the use cases and entities to the format most convenient to external services, such as database, storage, etc. Frameworks and drivers. These layers interacts with external system and frameworks, providing the set of tools, libraries from framework, etc. Important thing that we can see the rows. It's like rows that dependency rules that entities are independent of use cases. So, and use cases are independent of controllers. But the controllers dependent on use cases, the use cases dependent on entities. So let's overview some bunch of code. On this slide, we can see the class user is an entity, the basic entity. As I said, this abstraction contains the core business logic, the core like enterprise business logic, and contain only business logic required by such entity. Then let's focus on use cases. It's a pretty simple, like user management use case, like register user. On this layer or in the use case, we can define what action we can exactly do with an entity. Some register, processing, deleting, or something like that. And as we can see on this layer, we the entity. This layer is dependent on entity, but entity is independent of use case. And also, what I would like to add that use cases are interactors between the entity and external layers. So, repositories. It's abstraction that defined external interfaces for use cases. This is an interface to allow the use cases communicate with the external systems. Also implemented in the interface layer, which is an external to application business rules. if we talk about concrete repository, for example, here is described some storage user repository, whatever. It's inherit abstract methods from the abstract repository. It's also implemented on the interface layer. I asked myself why we actually need to inherit from user repository parent, because we see here like we have the database station, we use the database, and we usually not often change the databases. But for example, I asked myself this question, and also like my colleagues asked why we have to use that. But imagine the case when we have two environments and we need to use, for example, cloud storage and local storage. And we can use the factory that just create for us this repository and give the proper object. But what if we don't use the inheritance and don't use the interfaces for repository? We can just implement the different attributes or different name of method, and this won't work. Yeah, that's why it's important. I will show you later when I will show my solution for. You will see. So controllers. It handles HTTP requests and response or whatever, converting data from request, converting data from request from UI to another enterprise-wide business applications. Defined facade to application. Defined interfaces available for external services and applications. They also should be implemented in the interface layer. So then I think it's enough theory about clean architecture paradigm. Let's focus on some on end-to-end solution. So since one of my interests is like investments and cryptocurrencies and digital assets, I think it will be great to play with it, and decided to find something what will be interesting to me. And as everybody know that like cryptocurrencies are very volatile asset. So interesting if we can predict the market behavior. So I decided to take this small challenge to me. And yeah, and also I'm interested of Google Cloud, and focus on that, how it's possible to implement it with Python using Google Cloud, and see what is it. So I checked Google a bit and find some approximate solution for that on Google Cloud documentation. So we can see here few parts how it's possible to implement it. For example, if we have prepared some data, we can just focus on parts like storing data, engineering data, training model, and make predictions using like batch predictions API or online predictions API from Vertex AI or another AutoML service from Google Cloud. So, okay, looks good. How it's possible to apply it with Python and for my current challenge? I made something like this, some schema like this. So I have an external data source. I used Binance for that, Binance API for that. And so regarding this schema, we can focus on like next part of this like application, this solution. The fetching data, storing data, process this data, and train it. Train the model, and then fetch predictions using some external client or some UI. So now it's time to show my code. So let's see. First of all, focus on entities. For data set, I fetching from such API. It's K-line, USD margin based. So here we can see the main attributes for such like this entity is like a small piece of data set, like one item from the data set. So here we can see the parameters of this entity and also some basic methods that are used. Some representation, JSONifying, also some property methods for used then in processing. Oh my God, so difficult. I need to. No, I don't see it. My God, how to? Do you know how to zoom out on a three fingers? Oh my God, I'm a crabby. All right, now yeah, looks visible. Nice. Then let's focus on use cases. For my case, I found some bunch of use cases. It's 4 or 5 use cases. I defined it as first of all, we need to fetch the data, then store it somehow, process it, and store to warehouse BigQuery. And also then train the model and get prediction, but it is for future, for UI or some controller that will use to fetch it from API, from Vertex AI API. Let's review how it can be implemented and how I implemented that. And I put something here. Like I just here inherit the interface from base class and use the business logic of this use case and define the business logic for this use case here. Also the same for K-line process. I just processes and return the return the data in format required by a database adapter by BigQuery adapter. Then here is warehouse. That's what interesting thing that I talk in the middle of presentation about different environments. For this case, I used local environment and cloud environment. For prod, it's a cloud. For local development, and it's a local. So I just implemented the storage adapter factory and local storage adapter and cloud storage adapter, and it has the same interfaces, and it works. Also, it's easy to test that because the logic regarding the storing data, it's encapsulated in such classes. So tests is pretty simple. I will show you. Also the warehouse, but here is the same scheme how as for storage. Also I want to also there. Okay, just a few minutes. Okay, a few minutes. I'm finishing. Also, the interfaces. I have 3 interfaces for fetch, store, and trade the data. It looks pretty simple like this. I use the use cases from use cases and interact with cloud or local storage. Also, interesting thing for me, that was First time for me, I thought how to, because I interacted with cloud and thought how it's possible to use the infrastructure, what I can use for infrastructure as a code. I don't know, I know nothing about Terraform, so, and once I heard about Pulumi. It's like a Python, it's like infrastructure as a code service or library that we can use to define infrastructure in the cloud. And also it has a Python client. So I thought why I can't test it. Yeah, this code, it's like I tried it first time, but I can show you the example how it looks. Maybe it will be interesting for someone. So this Pulumi structures looks like this. It's like basic installation, and here's like a piece of code that, for example, we define like big. We want to define the BigQuery data set and BigQuery dataset and BigQuery table. We just use the Pulumi BigQuery dataset. Put there some parameters and make an export. Then we use the table and also make an export. And it's pretty simple. We just described that. And what we need is just to write in a terminal Pulumi up, and it push our changes to the cloud infrastructure. Sounds good, but also there is, when I implemented that and implemented the continuous delivery of my code to Cloud Round functions, for example, I faced with some problem because I need to fetch the latest image from Artifactory and yeah, Artifactory storage, and yeah, now I'm working for that, how it's possible to solve it. This is it from my side. I need to show you the final slide, but I don't know, where is it? Yeah. There is my contact. Maybe someone want to connect with me. Yeah, okay. And also, I want to say a few words. Thank you for organizer of this event, because it gives me give it to me a nice opportunity to visit Italy one more time again. And yeah, it is nice adventure. Thank you very much, and thank you very much for attention.